writing out quadratics. We have standard form, which is your y equals ax squared plus bx plus c. We had vertex form. Didn't use a lot, and we will start to use that more. Where it was y equals a times the quantity x minus h, quantity squared plus k, where h and k is the vertex. Okay. And then the last one, which I don't think we used more than maybe twice, was intercept form. And that's basically where you know where your zeros are located at. So the intercept form was y equals a x minus p x minus q. And these p's and q's, oops. Those are the zeros. It's the x-intercept. It's where it crosses the axis. Okay. So if your term was x plus 2, x minus 3, your zeros would have been at -2 and +3. Basically, this is just going to work backwards off. It is ridiculously simple to work. What's up? The p and q are your zeros. The x-intercepts. Okay, it's where it's running into the where it crosses the axis. All right. Very, very easy to work with. That's pretty good. Thank you. Walk, stand up.
Okay.
Walk up here.
Okay. Can I go to the bathroom?
Carry your books. We'll reenact it.
Oh, okay. What's the first? Do I just
P and Q.
Yeah!
That was really good. It's really heavy.
What?
Volleyball players.
Yeah, exactly. Volleyball players with lazy bugs. I'm just kidding. Not you. Just her. Yes. Anyway, so those are the three forms that we've used. What we're going to do is start with a vertex and a point and write it out. So we're going to take a vertex and some point on the curve, and we're going to write the equation given that info. So if I have a vertex at 2, -3, that means my h and k are 2 and -3. So what we're going to do is start with the vertex form, which is a x minus h quantity squared and a k. And we're going to substitute in our h's and k's. We have y equals a x minus 2 quantity squared minus 3. You okay with that so far? And then the other, I'm with you. Everybody's like that today. And the other thing that they give you an ordered pair. 4 and 1. What do you think the 4 and 1 will represent in this equation then? The y and the x, exactly. Therefore, what do you have to solve for? A. That's it. You're okay in the h and k, right?
Yeah.
Okay. The only other thing that was new is that they gave us
Wait, are h and k basically x and y?
no, the h and k are your
Oh.
vertex. It's your vertex, okay? It's the point of the vertex. Now I'm just going to substitute in 1 and 4. I have 1 equals a, 4 minus 2 quantity squared, minus 3. Yes, sir?
Isn't it kind of like, wouldn't this only be useful when you already have the graph?
No, you don't need a graph. If you have a point and a vertex, you can do this. It's just like point slope. If you have a point and a slope, you can write the equation, right? It's the same idea. It's just instead of a slope, finding the slope value, what we're doing is we're finding the curve, the a value. How fast is it increasing? Is it decreasing? And is it open wide or is it skinny? A value tells us that. All right. So in this case here, what's 4 minus 2?
2.
What's 2 squared?
4.
Okay. So we have 1 equals 4a minus 3. What do I do? What's a? So if a is 1, and we knew what h and k were, all we do is just substitute all back and you're done. Your final answer would be y equals 1, x minus 2 quantity squared minus 3. And did you really need to put that value of 1 there?
No.
So when you have vertex form, you will have to be given a point and a vertex. It allows you to solve for a.
So that's it.
That's your answer. It's going to say write the equation of the curve in vertex form. It's done. Okay. Let's do it again. Same idea. And notice they don't give me a graph. Do I need the graph? No. The only thing the graph allowed me to look at is the fact that I knew that the a value had to be positive because it was shown that way. All right.
All in one step. We have to stop.
You can throw it all at once if you want. I have no problem. Fill in the blanks. I know my points. This is my x, my y, my h, and k. Negative 3 is a. 8 minus 4 squared plus 5. Okay. Subtract the 5, we get negative 8. And 8 minus 4 squared is 16. And that gives us an a value of negative 1/2. And just rewrite. What's wrong?
How did you get rid of the square function?
What's 8 minus 4?
4.
What's 4 squared?
16.
And then your final, you just write it out as y equals, what was it, x minus 4. Okay. And like I said, you should never ever get one of these problems wrong because what you can do with your calculator is check it. Let me show you how. Take your calculators out.
It wasn't done. I can't. I thought you were just like I can't read. I can't read.
Let's go to the y equals button. Okay? Let's go to the y equals. And a lot of times when I have fractions, if my fraction is an easy number like half, quarter, something like that, I normally just type a decimal, just because it's faster. If you want to put the fraction in and type it through, that's fine. But I knew that the equation we came up with was negative 1/2 parentheses x minus 4 quantity squared, and then it was plus 5, right? So it should be that. Now, with any luck, if I hit second graph, you should get a table. Okay? The ordered pair that they gave us to use was, I forgot. 8, negative 3. So what we want to do is go through our table and just scroll. How to get to the table? Second graph. Ooh, look at that, we were right. 8 and negative 3. You can always go back and verify that your model, if you will, is correct. And that's it. Pretty easy, isn't it?
Yes.
The equation again? Why is it negative 4? Because h is 4, so it's x minus h. What are you getting?
not showing up correctly. It's got 80 equals -5.
You have a negative symbol here instead of minus. Hey guys, real common question, a real common occurrence. In the calculator, you have to use the negative button when something's negative, but anytime you use subtraction, you have to use the subtraction button. The subtraction button will not work as a negative button. That makes sense.
Really?
Yeah, these are weird. Okay. All right, let's look at the other method. Let's go with zeros. Intercept form. Okay. Do the same thing with intercept form. And it's very easy to tell when you have to use what. For example, I'm given intercepts and a point, whereas the other one I was given a vertex and a point. So very, very easy to figure out which one to use. If my zeros are at -2 and +3, that means my terms become x plus 2, x minus 3. You okay with that? Yeah. Well, think about it. When you go back to working with find your zeros, if you had parentheses setting equal to 0 and it was x plus 5 and 2x minus 1, your zeros would have been at -5 and +1/2. Yes?
The table on my calculator is all messed up.
Oh, we just did anybody else have a messed up table? Because I've seen that in a couple of people. Oh yeah, I'll send it. No big deal. What they were doing is that they had your table starting at 33. I'll usually start around like -4, and it was going by sevens. So here I have zeros at -2 and 3, which means I have y equals a, x plus 2, x minus 3. Oh no, what do you think we're going to do with that extra point? Math, you are very right. More specifically within math, what am I going to do?
What robot?
I have no idea.
It's not like a robot voice.
No, you just substitute back in there, guys. These things have to give you some other point on the curve. That way you know where things are going. All right? Point was at -1 and 2. So 2 equals a, -1 plus 2, -1 minus 3. From the point on the graph. It'll have to be given to you. You have to give the point on the graph. Okay?
Oh.
Yeah. It was given to us. This point was given. Okay? So now it's just a matter of, excuse me, filling in the blanks. So, -1 plus 2. 1. -1 minus 3.
-4.
1 times -4.
-4.
What's a?
-1/2.
-1/2. And then lastly, we just rewrite again. We just rewrite it. So you get y equals -1/2 x plus 2 x minus 3. You do not need to FOIL that out. It said, what is it in intercept form? Just leave it in intercept form. Yeah.
Why did you write +2 when it's
The p-value is -2. Remember, if my zero is at -5, my term is +5.
Yeah, no, I was looking at the one in the other. Never mind, I got it.
Okay? You guys do one. Take a minute and do this one on your own. Yeah.
Okay.
We're figuring out which quadratic equation has that point, those two zeros. That's what we're looking at.
Just know that these are the.
So we have 8 equals a, -4 plus 2, -4 minus 2. When I substitute straight in.
Intercepts
Why
are.
are you looking so worried, Shinky?
Wait, how did I get the -4? That's just all you use the whole time?
Yeah, it's going to be given, because remember, y equals a x minus p, x minus q. So this is your x and y. These are your p's and q's. That's all it is. Yes. Okay. So it's direct substitution. We have -2 here and -6. So 8 is 12a. 3/4?
Yep.
Wait.
No.
2/3.
2/3, sorry.
2/3.
And you get 2/3 for your value of a, which gives you a final answer of y equals 2/3 x plus 2, x minus 2. Yeah.
Sorry, does it matter which point goes in which one?
No.
Because it's, yeah.
What's 2 times 3? What's 3 times 2? Did the way you multiply matter?
Okay.
What property is that? Commutative. You get 1 billion points. So let's look at the weird
I'm already
one.
winning by so much.
Let's look at the weird one. Standard form. Standard form is the one that takes a little bit longer to go through. If I'm working with standard form, you'll notice that I have 3 sets of ordered pairs. And what I want you guys to see here is, in order to get this to work, you're going to have to write up 3 different equations.
Well,
I'll show you this. I have an x and a y. I have an x and a y. And an x and a y.
no.
So you have ax squared plus bx plus c equals some value of y. Well, in the first equation, my value of x is -1. So I get a -1 quantity squared plus b times -1 plus c has to equal what? 5. It has to equal 5. Okay? I do that again with the next ordered pair. A, 0 squared, b times 0, plus c has to equal 3. And then lastly, a 3 squared plus b times 3 plus c equals 9. Okay? Now, next to those, I'm going to go ahead and simplify it out and just leave everything in terms of the A, B's, and C's. I'll show you what we're going to be able to do here. -1 squared is 1. So this becomes 1a minus 1b plus, can I put a 1 in front of that c?
Yeah.
Because it doesn't change anything. 1c is 5. The second one, I know I don't need to write this, but I just want to show you. 0, 0a plus 0b plus 1c is 3. So what's c have to be? 3. 9a plus 3b plus 1c is 9. You wind up with a system of equations with 3 equations and 3 variables. You probably have done that at some point in time with substitutions, linear combinations, and all that. This one is really easy to do by hand because you know what c is. Therefore, you can substitute in c into both the top and the bottom equations and then solve with a linear combination and be done with it. But that's too much math. Multiplying and adding, things like that. Linear combination, when you, or it's like substitutions and stuff, elimination method. Linear combination is when you get a scalar and you multiply out and subtract.
Oh.
But that, like I said, that's too much math. Do you agree?
Yes.
Okay. So what we're going to do is we're going to take this stuff here And we're going to rewrite it. We're going to rewrite this as a matrix.
What?
We're going to rewrite this as a matrix. A matrix is a way of organizing data by using their coefficients. It is the easiest, fastest way to solve systems of equations. Matrices is something that we haven't taught a lot lately, past few years. The reason being, there's a button on your calculator. If you understand, if you understand how you set it up, you press a button. There's never a reason to go through argumented matrices unless you're in a linear algebra class in college. And that's all they work on, matrices. So, here's what we do. I want you guys to write down what's going to be called a 3x3 matrix. Matrices are made up of rows and columns. Rows, obviously if you're rowing a boat, go across. Row, row, row your boat. You have to go across when you row a boat.
I don't know, I'm a submarine.
There's always one. Columns hold things up. Right?
Have you never heard that?
Your desks have columns to hold up the top. So what we do is this. 1, -1, 1. 0, 0, 1. 9, 3, and 1. What we've done there is we've created what's called a coefficient matrix of our system of equations. Okay? Now, this is being multiplied by A, B, and C. And it has to equal 5, 3, and 9. Now, right now, you guys are all going, what? What happens here is nothing more than a one-step algebra problem. How do you undo multiplying? Division is the inverse operation of multiplication. Do you agree? Inverse can be rewritten as, so if it was AX equals B, I could undo A by taking its inverse, -1 power. You guys ever seen it like that?
No. Cosine.
Yeah, exactly. You're right. On your calculator, if you had to find the angle, the inverse cosine of something. Oops.
Wait, what?
Remember how you guys had to find the inverse cosine of 0.5? And it would give you some value or whatever? That's the idea. How do you find the angle? You take the inverse of it. Cosine of x equals something. Well, that's something you have to undo. So in matrices, it works the exact same way. What you do is that your answer column, A, B, and C, is going to equal the inverse of matrix A times matrix B. Matrix A, you want to do it by hand?
No, I'm trying to follow along though.
This is, but you're okay with this being one step?
Yeah.
5x equals 10.
Yeah, what did you just do?
Math. What we did here is a purely long way written out of how to solve a one-step algebra problem. You take the inverse operation. The inverse is multiplied, you just take the inverse. Inverse is that -1 button. On your calculator, there's a button that says x to the -1. It means inverse. That's all it is. So there's also a button in the calculator that creates matrices. Alpha, zoom. No, it's quicker to do alpha zoom. Alpha zoom. Alpha is the, zoom is right in the middle. Alpha zoom allows you to create a matrix. It has rows and columns. The first matrix we're going to create is 3x3. Okay? So I have to change it, so I have to scroll up and change this over to a 3. and then scroll back down and hit OK. Now, some of you guys have the older operating system. Looks very similar to it. Instead of being, you want 3 by 3, 3 rows, 3 columns.
Holy cow.
Okay. There you go. What's that? Alpha zoom. Hit alpha zoom. Everybody else not get this? You got it? You get it, JC? Alpha zoom. Change the columns. We're okay? All right. So now we're just going to fill in all of our coefficients. Our coefficients were 1. You can't hit enter. You have to hit to the right key to switch to the next one. 1, it was negative 1, 1, 0, 0, 3, 9, I forgot, 3, 1.
Yeah.
Oh, yep, thank you. That would have screwed up a lot of stuff. Okay, so once you get this coefficient matrix put in your calculator, hit x to the negative 1. That will automatically find the inverse of that matrix, which is a long way of doing multiply the tails, subtract the ups all over the determinant of the other. It's a pain. Yeah. If we have time at the end of the year, I will go through it with you guys, but I would never make you do a matrix that was more than 3 by 3 by hand, because that's just awful. I mean, I might, but you never know. Yeah. Now to this, we have to multiply it. Remember, we have to multiply it by our column matrix, a 3 by 1. Rows go first, 1 column. So go back to the calculator. We're going to go alpha zoom, and I need to change this to 1 column. Alpha zoom, change it to 1 column. The answers had to be, what were they?
539.
539, 5, 3, and 9. Hit enter. Those stand for A, B, and C.
Oh, no.
What am I going back to? B is 539. So this here now becomes, this is my A value, there's my B value, my C value. So I can write out the quadratic equation. Y equals 1x squared minus 1x plus 3. And that's the equation of the curve that had those 3 ordered pairs. Yeah, 3 by 1. I know. And once you get used to it, it's really easy to do. I changed it to a 3 by 1. Yeah, the coefficient matrix, the 3 by 3 has to go first. There are a lot of little rules that work with matrices. When you multiply 2 matrices together, the number of a number of columns in the first one has to equal the number of rows in the second one. If it doesn't, it won't work. So if you accidentally do it, you'll get some weird numbers and stuff like that. Okay? Matrices are so ridiculous easy to work with. Okay, let's do another one. Because you don't have to, because it's the easiest way to do it.
Wait, hold on. This isn't working. Oh, why is
That's what the answer's for. That's the ABs. That's the ABs and C's for the quadratic and standard form. Okay.
Oh, that's right. Okay.
What is the A?
Okay. All right. I figured it out.
What's that?
The A, the inverse of A times A.
That's just what it looks like in long form. That's all it is. When you're dealing with matrices, matrices are labeled with capital letters. Guys, this is a great question. She was asking, why is it AX equals B? Why did I write it like that? matrices, when we define them as just capital letters. So it's matrix A times X equals matrix B. Well, in order to get X by itself, you take the inverse of matrix A times matrix B, and that would give you the solution. It's just matrix notation, I guess if you want to call it that. What were you going to say? It doesn't work. In order for this to work the right way with the calculator, you use the inverse button instead of divide. Because the matrices can have an inverse, but they can't divide. I mean, it's, yeah.
So that's kind of like what they're trying to get.
Okay. So once we go back to the other one, remember we have the generic equation is ax squared plus bx plus c is y. Okay? As you go through it, all you're doing is substituting in 3 times. Negative 2 squared is 4, so I get 4a minus 2b plus 1c is negative 1. Guys, enough. Direct substitution. A lot of times, some of these numbers are going to be such that you could probably square them in your head and write it out. Okay? Shouldn't be very, very difficult. Wait.
Wait, why did you subtract the b? Like the minus b,
X was negative. When I substitute in for x, I get b times negative 2.
oh.
Negative 2b. Or not 2b. 1a plus 1b plus 1c has to be 11. And then lastly, we have 4a plus 2b plus 1c is 27.
It just clicks. It's like,
Oh, it's like a Lego.
Is c always going to
C, yeah. C is always going to be 1 because you don't have, we're only dealing in second dimension. That C value will be 1.
Until you introduce like 3-dimensional
We're
graph.
not doing any of that. Okay.
oh,
Yes.
thank you so much.
Okay.
He scared me.
So now you just put them in the calculator. What's wrong, JC?
Oh, no, nothing.
Okay, I thought you had that look again.
No.
Not this time.
Nah, Ava Mouse.
All right, so let's see here. We have the calculator would be helpful.
This is
Alpha.
wait, give me hold up.
Yeah.
Oh, I don't. Never mind.
You all right?
Yeah.
Okay. Coefficients. Let's see here. What were they?
4, 2, 1.
4, negative 2, 1. The next one was all ones, wasn't it?
Yeah.
Was it 1? All ones, yeah. Last one was 4, positive 2, and 1. Hit the inverse button. Another matrix. 3 by 1. We used to make you guys have to solve these things by hand.
Ava Mouse.
I don't know.
What did you say?
Ava Mouse.
You were asking if I can use the button that says matrix down here. You can, but it's a lot. It takes a lot more to open those up and edit them. It's a lot quicker with the shortcut. That's all. What was my answers again? It was negative 1, 11, positive 27.
Yep.
Yeah.
Any luck? We should get meh. 371.
Satisfactory.
You guys get 371?
I got 374. Just kidding. I don't know how to read. 371.
And it's so easy. That's usually where things will get messed up. If you miss a sign when you're putting stuff in, that's it. So, like I said, using the calculator for some of these things is just so easy. It really is. So you didn't have to solve a 3x3 system by hand.
We have to use this on the test.
There wasn't an answer.
That makes me want to cry.
There'll be calculator, non-calculator. Am I going to make you do this by hand?
Yes.
No.
If he didn't teach us how to solve it by hand, how was he expect us to learn
Oh, you can solve this by hand. It's a pain, but you can do it.
Extra credit.
It's
right there.
just substitution. Really, it's just direct substitution. It's not fun. I mean, you just get, what I would do each and every time, I would take this, solve that for C and say C equals 11 minus A minus B. And I'd take that and substitute into here and in here. Then all of a sudden I have two variables, two equations. But yeah. Yeah, because this is your AB, these are your coefficients then. You'll be 3x squared plus 7x plus 1. And that's your equation. That's your answer.
Homework, we told you was
Okay.
awesome. We go, okay.
Questions?
Homework.
I'll get you. There is regression in this section as well, but in the middle of going through it with the third hour, I remembered, oh, we do regression all at the same time, because each one of the units that we work on throughout the year, there's going to be some graphical thing with buttons that we'll use on the calculator. It's convenient that there's buttons on the calculator. But we'll look at all that at once instead of trying to split it up between each unit. So I have these for you. It's odds for all of them, okay? That way you can check your work, okay?
Looks like a lot.
It really isn't. It shouldn't take very long.
So like 20 minutes. 6 weeks later.
9 problems.
I'm asking a lot of you, Mr. Williams. I know. I will try my best to lower my expectations. Okay? And once you get going on that calculator, guys, it's so easy. So easy.
Do you
Okay?
have to do them all on the calculator?
No, I'm saying just the matrix ones.
How do you do that real quick?
Those are the last
Do
three.
you know which one do I do?
It's on like, because it gives you like vertex, like you use vertex, you get intercepts, and then point you use intercept.
Really hard to like say how to use it.
You ever had that happen?
No, I haven't.
They like